Hi guys, welcome to this video, which is just going to be a quick one showing how we calculate empirical formula for substances. So I've got a question here for you, which is showing that we've got a compound which is comprised of 43.4% sodium, 11.3% carbon, and 45.3% oxygen. So the question is, what is its empirical formula? All right, so to start off, what we need to do anytime there's an empirical formula and we get a percentage like this is to treat the percentage as a mass. So I'm going to start off with the sodium here, and I'm going to work out using mass over molar mass, okay? And so I'm going to take 43.4% as the mass of sodium, and the molar mass off the periodic table was 22.99 grams per mole. So if you work that out, you'll get a value of 1.89. So that's what I'm going to use as a value to compare to the carbon and the oxygen. So if we do the same for carbon, if we do mass over molar mass and we work out 11.3 grams, so from that 11.3% up here, over the molar mass, which is 12.01, we get a value of 0.94. So there's that one. And then we do the same for oxygen, mass over molar mass, so we get 45.3 grams over 15.999 grams per mole off the periodic table, and we get a value of 2.83. So now that we've got these values, these are the ratio of the atoms to each other within the formula. So what we can do is we can use these ratios to work out what the full number ratios are. In order to do that, what you do is you choose the lowest value. So here, 0.94 for carbon is the lowest value. So what we're going to do is we're going to divide everything by 0.94. So if we do that for carbon, we'll get a value of 1. All right, if we divide 1.89 up here by 0.94, we get a value of 2. If we divide oxygen 2.83 by 0.94, we get a value of 3. So now what we've got is the ratio 1 to 2 to 3 of our substances, okay? And so what we've got is 2 sodiums, Na2, 1 carbon, and 3 oxygens, Na2CO3. So that is the empirical formula for sodium carbonate based on those percentage compositions. So it's pretty straightforward. Just take the percentages that you get up the top here. So these ones up here, take these percentages, make those into your mass. All right, so take each of those as the mass in grams. Then when you're going through, use your mass over molar mass here to work out what that value is, just taking the mass and dividing it by the molar mass off the periodic table to get these values, okay? Once you've got these values here, just find your lowest value, which in this case was carbon at 0.94, make that equal to 1, and then work out your ratio. What you might find when you're working this out is, if I just change my pen color here, so you can see, let's say, for example, that you got a value of 1 here, 1.5 up here, and then you got 2 here. Because this one of 1.5 is a half number, you need to make that into a whole number. So that's going to, the nearest whole number you can make it to is up to 3 when you multiply it by 2. So you multiply everything by 2, multiply that by 2, all right? And so you'll now have a ratio of 3 to 2 to 4. That should be a 4 down there, sorry. All right, so if you end up, when you go through this first step in red, where you're dividing everything by the lowest number and you end up with a decimal, okay, just convert that into a whole number. Normally you just need to multiply by 2 because you've got a half number, and that will give you the whole number ratios that you need. So hopefully this is a good, helpful little example for you as you're going through and doing some calculations for empirical formula. Thanks, guys.